Let's change out some units in the metric system going from one mass to another mass. Now remember, for your prefixes you've got mega, which is 10 to the 6th power as it relates to your base, and then right around your base going bigger you have deca, DA, then hecto, H, kilo, K. From your base going to smaller units you have deci, D, centi, C, milli, M. Then when you get to another step of 3 you get to micro, which we use the Greek letter mu. Then 10 to the -9th power as it relates to your base is nano, whose symbol or abbreviation is N. And then 10 to the -12th power as it relates to your base is pico, P. Alright, so we can use this chart then to do these unit conversions. So if I want to change 12 kilograms to grams, alright, so I am in kilograms, which is right here, and I want to go to grams, which is my base. So looking at this chart then, to go from kilo to base, it would be 1, 2, 3. So we're going to, and notice that we went right, so we're going to go right 3 spots with our decimal point to do the conversion. So right here the decimal is after the 2 and the 12, so if I go 1, 2, 3, this is where I want my decimal point to be. I'm going to need to put in some filler zeros, so this would be 12,000, and then my units now are grams. If we wanted to set up an official conversion factor, we would put 12 kilograms over 1. We're going to set up another fraction that we're going to multiply. This is my conversion factor. The units I'm trying to cancel, which is kilograms, go on the diagonal. And then because I'm connected to my base, we can use just what's happening with these, either the exponents on the power of 10 or these multiples, because these values right here talk about how the prefix connects to your base. So a kilo is 10 to the 3rd power as it relates to your base. So 1 kilogram is 10 to the 3rd power grams, or if you want you could write that as 1,000 if you'd rather write it like that. The kilograms are on the diagonal, they cancel. Grams are my final unit, so that would be my unit for my answer. And then looking at what's happening with the numbers right here, because I am multiplying the 12 by a power of 10, you're going to move the decimal point right, and you move it right the same number of spots of what this exponent is, or however many zeros are in that expanded form. So we're going to move it right 3 spots. So again, if I take my 12 and I move the decimal point right 3 spots, which means I need 3 filler zeros, I get the same answer as I did by looking at this little table up here. All right, another example, let's change 250 milligrams to micrograms. So remember, micrograms as an abbreviation would be with that Greek letter mu. So I can come back up here and use this table again to help us. Move this down a little bit. All right, so looking at, I'm in milli, which is right here. I want to go to micro, which is right here. Okay, so from milli to micro is a step of 3, and if I look at what's happening here, it would be 1, 2, 3 to the right. So then if I want to take this number down here, the decimal point originally occurred after the 0. If I want to go 1, 2, 3 to the right, I'm going to need some filler zeros. So this would then be 250,000 micrograms for my final answer. Setting this up with a conversion factor, if you prefer that approach, I would have 250 milligrams. I'd put it over 1. I'm going to set up my conversion factor where I'm going to have milligrams on the diagonal. And then looking up here at my table, the exponents are off by 3, with micro being the smaller of the units. So that means I have 10 to the 3rd power micrograms and 1 milligram. So that I can use that information to fill out my conversion factors. The milligrams on the diagonal cancel. my final answer would be in terms of micrograms. And then again, because I'm multiplying by 10, I want to move the decimal point right, whatever the exponent on that 10 is. So because the exponent on the 10 is 3, I want to move the decimal point right 3 spots. So again, I get my 250,000 in micrograms. All right, what about working with one with the tons? So what I want to change 46,000 kilograms to metric tons. Okay, so metric tons is not on this table. So we need to actually remember the relationship that in 1 metric ton, this is equivalent to 1,000 kilograms. So in order to get a better sense of what's going on, again, we're going to set this up as a conversion factor. So the given information, the 46,000 kilograms, I'm going to put over 1. The units I'm going to want to cancel is kilograms. So when I go to set up my new fraction, kilograms goes on the diagonal of where it was. And then here's where I'm going to use my conversion factor. 1,000 kilograms is the same as 1 metric ton. So 1,000 will go next to my kilogram label. 1 metric ton goes in the numerator. My kilograms units are on the diagonal. They're going to cancel. Right. And then you can take your 46,000 and divide it by 1,000, or you can see 1,000 as being 10 to the 3rd power. Because we are dividing by a power of 10, we want to move the decimal left, whatever this exponent is. So because the exponent on this 10 would be 3, we would want to move the decimal point left 3 spots. So in 46,000, if I move the decimal point left 3 spots, maybe I'll write that down here as a work step, as opposed to putting it up there as part of the expression. So if I move the decimal point left 3 spots, that's where the decimal point is going to end up. So then my final answer is 46 metric tons. And on those ones, please don't just write tons. Ideally write metric tons, because we talked earlier that there's 3 different types of tons. There's the metric ton, the short ton, and the long ton. They can get a little confusing, obviously, so we don't just want to sometimes throw out the word ton. We want to be very clear about what ton we're using.